Hello everyone, welcome back to the Kean Tutoring Center. My name is Anthony, and today I will guide you on the relationship between polynomials and exponents. So to start, what is a polynomial? Well, a polynomial is defined as the expression of multiple variables containing different amounts of the same variable. When I say variable, it's just your letter. So it could be X in most cases, it could also be A, B, C, any letter of the alphabet really. A couple of different types of polynomial expressions are displayed here below. There are single term monomials, so our 5x, or it could be, 4x, 3y. We have our binomials, so it's two terms, right? So we have 6x minus 8. We could have 2b plus 4. And then we also have trinomials, which is our three terms, which is an example would be x squared plus 8x plus 16. And then anything beyond would be just a generic polynomial. So for an example, it would be x to the third plus 5x squared minus 6x plus 7. So that would be an example of just a straight up polynomial. Other examples I have below here. We have x squared minus 25, so this is binomial. And for our x cubed plus 5x squared minus 3x plus 16, so that's four terms. So this would be just a generic polynomial. So now we move over to what exponents do by themselves. In many cases, exponents are just another way of minimizing the amount of times you have to write a term when it's multiplied by itself. A few examples are 2 squared right here. So that would just be the same as saying 2 times 2. And then obviously you'd either plug it into the calculator or you'd write out the math and it would give you 4. Same thing for 5 cubed. So that would be 5 times 5 times 5, which gives me 125. And then we also have 4 cubed minus 6 squared. So in other words, you're just rewriting it as 4 times 4 times 4 minus 6 times 6, and that's equal to 64 minus 36, and that's equal to 28. So in other words, you could use exponents to really minimize the amount of writing. So notice how it goes from something large like this, and it could be written into something small like this. So I'm going to give you a moment. You could pause the video here to do these practice problems on your own. Give yourself a couple minutes, and then unpause when you are ready to work through them with me. Okay, so the reasons I give you these type of problems, it's more just to test your understanding of how you could shorten down or expand terms based on their exponents. So for example, we have 7 times 7 times 7 minus 8 times 8. So I see 3 sevens here, so I could rewrite this as 7 cubed, and that will be subtracted by, so I have 2 8s here, so this would be 8 squared. And that's equal to a number. So if you have a calculator nearby, you can plug it in here. I'm going to do it as well. It'll be my 7 cubed is equal to 343, and 8 squared is obviously going to be 64, and that's equal to a number, just to show all the steps. And then 343 minus 64 is going to be 279. Not too bad, right? Okay, I'm going to use a different color for the second problem. So now I give you it in the exponential form, and I'm going to expand it, and then I'm just going to solve out the problem again. So I have 9 squared. So 9 squared is going to be equal to 9 times 9, because there are, the exponent's 2, so that means that there are 2 9s, and then minus 3 cubed, so that means that they're going to be 3 3s. So I have 3 times 3 times 3, right? Now, just to do a quick refresher, you want to follow the order of operations here, because that's just the way that's the main way you're going to solve these type of problems. You want to make sure you follow order of operations. So 9 times 9 is 81, and I'm subtracting, so 3 times 3 times 3, or 3 cubed, that's going to be equal to 27, and that's equal to a number. And then 81 minus 27 will be 54. Again, not too bad, right? Time to put it really all together, right? So now you may be wondering, how do exponents affect polynomials? Well, it really depends on what you're given. In some cases, you'll be given a exponent inside a parentheses and an exponent outside the parentheses. So for example, we have 2x squared versus 2x in a parentheses squared. You may be wondering why those are different. Well, it's because it's just going to change the relationship between how the parentheses or whatever is in the parentheses is going to be affected by the exponent, which we'll see in the next slide right here. So notice, right, if I have 2x squared and the squared is on the x, that means that it's only really affecting the x, right? Because it's not attached to the entire monomial, it's only attached to the variable. In the same case, right, you see how it's 9 squared minus x. So the square is only on the 9. In other words, it's going to be 9 times 9 minus x, and that's where I get 81 minus x from. So I'm going to give you a moment to try these next two, and when you're ready, you can unpause the video. All right, so I'm going to do this first one in green. So notice, right, 81x cubed. So the exponent is only on the variable. So similarly to the first example up here, 81x cubed is equal to the same thing. It's just 81x cubed, right? And for the second one, so we have 5 cubed plus 2x squared, right? So now we're dealing with multiple exponents in the problem. So if I have 5 cubed, that's the same thing as saying 5 times 5 times 5 plus, and now notice it's 2x squared. Again, the squared is just on the x. So I'm going to leave it as is, 2x squared, right? Now I have my 5 times 5 times 5, and that's just going to be 125 plus 2x squared. I'm just going to circle F1. Okay, so now we're going to compare that to the other half, right? So now you may be wondering, what's the relationship if the exponent is on the outside? Well, if the exponent's on the outside, then all that means is that it's going to affect the entire polynomial, right? So if I was to look at this, right, then I would say, okay, 2x with the parentheses squared. So that means it's 2x times 2x, right? So if I have 2x times 2x, then we remember that the numbers multiply the numbers and the variables multiply the variables. So 2 times 2 is 4, and there are 2 x's, so it's going to be x squared, right? So now, same thing if I was to have it on the outside of a binomial, excuse the typo here. So this really is supposed to look like, it will be 6x minus 3 squared, right? And then it's recommended to use the foiling method, right? So a quick reminder of what FOIL is. It just means that when you have two binomials multiplied by each other, you're gonna rewrite them out, and what you're gonna do is you're just going to follow the FOIL tactic, which is first, outer, inner, last. So it's your first term right here, right? So it's going to be my first term of 6x times 6x. So that would equal 36x squared, right? Because it's 6 times 6, 36. X times x is x squared. Then I go my O, which is outer. So 6x times negative 3, right? So that's going to be minus, because it's a negative, times a positive, negative 18x. And then I'll do my I, which is inner terms. So I have negative 3 times 6x, and that will give me my next term, right? So we have 3 terms so far. So it's going to be, again, negative 18x since it's mirroring. And then we have the L, which is for last terms, right? So negative 3 times my negative 3, and that's going to give me a positive 9. Now you may be wondering, are we done here? No, because we want to combine like terms, right? We want to make sure that we compact this problem as much as possible. So there's only one x squared, right? So that's going to be my 36x squared, and my plus 9 can drop down as well. So we really got to think about the relationship of negative 18x with negative 18x, and it's just subtracting, right? So it's negative 18x minus 18x, so it's the same thing as combining negative numbers. So that would give me negative 36x. And this would be the final answer to the second example in this slide. Alrighty, so now I want you guys to try the examples here. And don't be intimidated that it is a cube power now. You're just going to do the exact same thing as before. Okay, so when you are ready, you can unpause the video. And let's do this together. So I have 4x cubed. So in other words, this could be rewritten as 4x times 4x times 4x, right? So all you really have to do is just multiply straight away. It'll be 4x times 4x. Let's do this first pair together. So 4x times 4x is 16, right? Because of the 4 times 4 is 16. And then the x's is just going to be x squared, right? And then my last 4x just comes down. And then we just do the same thing again. So now we just do number times number. So 16 times 4 is going to be 64. And now x squared times x is going to be x cubed, right? Not too bad. And then for my second one, I am going to do it here on the right side. It's 2x plus 8, plus 8 squared, right? So this could be rewritten as 2x plus 8 in a parentheses times 2x plus 8. Alrighty. So now we're just going to follow FOIL again, right? So quick refresher, FOIL is first, outer, inner, last. So we'll do it here together. 2x times 2x is my first term, so that's going to be 4x squared. My O, my outer term, right, is going to be the first 2x times the positive 8. So that's going to be 2 times 8, which is 16. That's going to be plus. And then we have the x. And then we do the same thing again, right? Because now we have our i's. And since it's the same, it's the binomial times itself, it's just going to mirror again. So 8 times 2x, that's going to be equal to plus 16x. And then my L, last term, is going to be 8 times 8. And that's going to be my plus 64. And then you ask yourself, are you done yet? And you say, wait a minute, no, I'm not. I still have like terms in this problem. So my like terms here are 16x and 16x. So my final answer will be 4x squared. You combine your 16x plus 16x, and that will give you 32x. And then you bring down your last term, which is your plus 64, right? And that is your final answer. All right. So to kind of wrap things up, right, we have many cases that you could run into polynomials with exponents, and it's all about just recognizing the relationship between them, right? You want to make sure you can distinguish if the exponent's just on the variable, then you don't really have to do much to the problem, or if the exponent's on the outside, then obviously you'll know you'll have to multiply the monomial or the binomial together in order to solve the problem. The main takeaway to get from this is that you want to understand that the exponent only affects the corresponding term if inside the parentheses. So for example, just again, a reminder, if it's something like 3x cubed, then it's really only affecting the x, right? So it's 3x cubed. Versus if it's outside the parentheses, then it'll open up the problem. So something like 4x squared, you're just going to open it up, right? You're going to multiply whatever is in the parentheses by itself. So it'll be 4x times 4x, and that's going to be equal to 16x squared. I hope you found this video very helpful, and go crunch those numbers.